Hello everyone, welcome to this session on chapters formula bonding. So far we discussed about the covalent bonding. I would say that before that we said that there are two bonds, or there are two types of bonding. There is covalent bonding and the electrovalent bonding. So far we've covered all about the covalent bonding. So today, uh, let's move on to the electrovalent bonding. So this is the other type of the bonding, and here we'll start discussing with the concept of the electrovalent bonding. So here we're going to see the meaning of the electrovalent bonding. Uh, this is the type of the bonding that occurs when an atom it transfers electrons from its outermost shells to the outermost shells of the another atom, usually a non-metal. So this is different from the covalent bonding, whereby in this kind of bonding, it occurs just when an atom transfers its electrons, especially those from its outermost shells to the outermost shells of the another atom, which it is usually a non-metal. Now, in this type of bonding, an atom of a metallic element or group loses its valence electrons from its outermost shells. Now, the most electrons, the lost electrons, they are the ones that pass over to the outermost shells of an atom, which with which the metal is combining. So this is what happens in the electrovalent bonding. Now, by so doing, the metal will become the positively charged due to the excess protons left on the nucleus, while the nanometal will become the negatively charged due to the extra electrons it has received. Now, the particles are then known as the ions, and the positive ions are the ones that are called the cations, while the negative ions are the ones that are called the anions. Now, when metal atoms they lose the electrons to attain the electronic configuration of the nearest noble gases, while the nanometals atoms gain electrons to attain the electron configuration of the nearest noble gases. This means that an electron octet is left behind in the metal and created in the nanometal. So that's basically what happens generally in the electrovalent bonding. Now let us consider the formation of the foreign compounds from the combination of the metallic and the non-metallic atoms. So we are going to see the various examples of how this electrovalent bonding occurs. Now, example one, that is the sodium chloride. Before combination with the sodium atom, which has the following, the protons, it has 11 protons, while the electrons are basically 281 uh, from the uh, from the electronic configuration. While talking about the chlorine atom, it has 17 protons and the electrons 287. Now, after the combination, this is what happens. The sodium ion still have the 11 protons, but the electrons they become remaining to 8, while the one that was from the sodium it combines to the chlorine atom, making it the chlorine ion having protons that is 17, and the ions of the chlorine they become 288, making it a stable compound. A stable component. Now that's what happens in the covalent bonding. Now, both ions now put this, both of these two, the sodium and the chlorine, they both possess the stable outer octets, like a noble gas, as you have seen, in the above slide. Now, no molecule of the sodium chloride is formed, while the cations, which are of the sodium and the anions of the chlorine, they attract one another and they arrange themselves into a rigid solid shape called a crystal, but they remain quite separate. Now the combination, they can be expressed the only ionic form as sodium chloride. Now let's move on. As the ionic compound is thus a cluster of the ions in which a positive ion is surrounded spatially by a number of negative ions, while the number of positive ions similarly surround each negative ions. So that's the ionic compound. Now the force holding together the or positively charged ions is what is called the electrostatic force, and hence the name the electrovalent bond. So you get the name of the electrovalent bonding from the force that is holding the charged ions within a given ionic compound, which is called the electrostatic force. Now, as you can see here, this is a illustration of the arrangement of ions in the electrovalent compound. As you can see them, they are arranged accordingly. So joined or they are forced together by this electrostatic force. I hope that's clear. Now, the other example is the calcium chloride. This calcium chloride is the other example that in this calcium, in the calcium ion, the two excess nuclear protons, they produce a double positive charge, and the two electrons released from the outer shell of the calcium atom are equally shared between the two chlorine atoms. In such the chlorine ion, the excess electron produces a single negative charge, that is the sodium chloride. Now, here is what happens in this. Before the combination, this calcium atom has 20 protons and the following electrons, 2882, and there are two chlorine atoms having the same protons, 1717, and the electrons, 287, 287. Now, after the combination, the calcium ion, it loses the two electrons, giving out the two electrons, leaving the 20 protons in the 288 electrons, and the two uh, electrons that have left the calcium ion moves to the chlorine ion, making it a stable ions, as the protons remain the same, 1717, while the electrons, they become 288, 288. Now from there, as you have seen, so that's just the other example of the electrovalent bonding. So that's all clear. In this video, we've seen the concept of the electrovalent bonding. We've seen the meaning of it, and we've briefly seen the two main examples. Well, now you can identify that this is a electrovalent bonding. I hope that's all clear. Thank you.